Hey there, I'm back with a new video. Inside this video, I'm going to explain about how to containerize our Spring Boot applications or any Java-based applications. And when I try to containerize my Spring Boot application, I'm going to use three different approaches. And these are the most commonly used approaches by the developers. And these three approaches, like you can see, Dockerfile approach, Buildpacks approach, and the last approach is with the help of Jib. In the process of demo, I'm going to show you all the process that you need to follow, all the updates that you need to make to your Spring Boot application to containerize the same. So in order to discuss about this concept, first we need to consider any Spring Boot Maven based application. For the same, I'm going to take an already existing Spring Boot application inside my local system, and using the same, I'm going to explain how to containerize your application. So let's jump into the IntelliJ IDEA and try to import the Maven project. Here I'm into my IDE. I'm going to click on this open option, and post that I'm going to look for my Maven application. So here under storages, workspaces, under this folder, I have another folder with the name Dockerfile, and inside this I have a Maven application with the name accounts. So let me open this Maven application. So this is a simple Spring Boot application which exposes REST APIs to the end user, using which the end user can fetch, create, update, and delete the bank accounts inside a bank application. If you can open this accounts project inside the source folder, I have a controller class with the name accounts controller. Inside this controller, you should be able to see all the 4 REST APIs that I have built with the methods create account, fetch account details, update account details, and at last we also have delete account details. I'm assuming you are familiar with Spring Boot applications. That's why I'm not going very in detail about this application. And post this, I also want to highlight that this application uses an in-memory H2 database. If you can go to the application.yaml, here you can see I have configured all the H2 database so that we don't have to worry about the installation of other database inside our local system. With this, I'm assuming you're super clear about what is this Spring Boot application. Now coming to the purpose that why we are talking today is to containerize the Spring Boot application. The very first approach that I want to demo here is with the help of Dockerfile. This is the most basic approach because with the help of Dockerfile, you need to provide all the instructions to your Docker server on how to build an image from your Spring Boot application and how to containerize your Spring Boot application. For the same, first we need to create a file inside our accounts project. The file name is going to be Dockerfile. So let me give the file name as Dockerfile, and there should not be any extension to this file. So let me create this, and you can see as of now it is an empty file. Here inside this file, I'm going to paste a few Docker instructions so that we can discuss. The very first instruction that I have to my Docker is with the help of this from command, I'm giving the base Docker image that my application need. Like in order to run any Spring Boot application, we need an JDK or JVM. That's why I'm trying to give instructions to my Docker saying that to containerize my Spring Boot application, first I need a base image with the name OpenJDK, and this is the tag name. So here I'm trying to use the JDK 17 version. So once we give this from command, post that I'm just giving some metadata with the help of this maintainer. Inside this maintainer, I'm just giving my domain name, which is easybytes.com. So this is just a metadata about who maintains this Docker image. After this, I have a copy command. What I'm telling with this copy command is there is going to be a target folder inside my project. If you can see, this is the target folder. And inside this target folder, when I try to build my Maven application, I'm going to get a jar with the name account snapchat.jar. The same I have mentioned here. The same jar I want to copy into the Docker image with the same name. You can see there is a space here. So with this is the source path that I'm trying to copy the source jar, and this is the destination inside my Docker image. Since I don't want to create folders inside my Docker image, I'm just trying to copy directly without any folders. Once this copying is completed, I'm trying to tell to my Docker, whenever a container is trying to be created from my Docker image, I'm telling please use this command to start the container. That's what we are trying to convey with this entry point. So this is just a Java command. Using the Java command, we are trying to execute this jar which we have copied in the previous step. So this is the most basic Docker file that we can write to containerize a Spring Boot application. I hope you're clear. Now let me try to show you the commands that we need to follow to generate a Docker image for this project and how to create a container from the Docker image that we generated. For the same, first you need to make sure you have installed Docker inside your local system. So please make sure you have installed Docker inside your local system. And you can see I have my Docker running here. If I click on this dashboard, you should be able to see all the images and containers inside your Docker server. So please make sure you have the Docker running inside your system. Otherwise, all the commands that we're going to discuss is not going to work. You can also confirm if the Docker is installed properly or not by using a command inside your terminal. So this is my terminal, and here I'm going to execute a command which is docker version. So whenever you execute this command, you should be able to see all the version details about your Docker client and Docker server. So I'm good here. Let me close this terminal. Now I'm going to open the terminal inside the location where my accounts project is present. So let me open the terminal here. So this is the terminal right now. I can execute the command pwd, which is present working directory. And this confirms that I am inside the accounts folder. The very first command that I need to execute here is, first I need to generate a jar for my Spring Boot application. Post that, using the same jar, I'm going to generate a Docker image. For the same, let's try to execute the maven clean install command. So the command is mvn clean install. With this command, our application will get compiled and a jar file will get created inside the target folder. Of course, you can also do a clean build inside your IDE, and that will also create a jar inside your target folder. So now you can see the build is successful and I should be able to see a jar inside my target folder. So let me confirm the same. Inside my target folder, there is a jar which is generated right now. You can see it generated just now. Now I'm back to the terminal. Let me clear my terminal. Now, as a second step, I'm going to execute a Docker command, and the Docker command is docker space build space dot space -t. And what is the Docker image name? The Docker image name that I want to give here is easybyte/accounts. So please make sure you are giving a proper Docker image name. So the standard that we need to follow here is, first we need to make sure that we are giving the Docker username that we have created while creating an account inside the Docker website. So this is my Docker Hub website where I have logged in. You can see my username is easybyte. That's why I have to give the same username inside my Docker command also. Post the username, I can give what is the image name. The image name that I want to consider here is accounts. Docker build is a command which will generate a Docker image based upon the instructions that you have provided. And with this dot, I'm telling to my Docker server that the Docker file is present inside the same folder where my terminal is executing the command. You can see we are right now into the accounts folder, and inside the same folder we have the Docker file. That's why we need to give dot here. And the T here indicates what is the tag name that we want to consider for our Docker image. So this is the complete Docker image name that we want to consider. So now I'm trying to execute this command. With this command, my Docker server will try to generate a Docker image for my Spring Boot application. I can also confirm the same by executing the command docker images. You can see there is a new image created inside my local system just 11 seconds ago. Now, using the same Docker image, I want to create a container, because at the end of the day, we want to deploy our Spring Boot application as a container so that our end user can use our application. The Docker command that we need to execute in order to create a container from this Docker image is docker run -p. P indicates what is the port mapping that we want to provide. The port mapping that I want to provide is 80808080. This means I want my Docker container to expose to the outside world with the port 8080. And after this port mapping, I need to give what is the Docker image name. The Docker image name is easybyte/accounts. So with this command, if I execute, a container will be created based upon my Docker image. So now my Docker container started, which means my Spring Boot application started at the port 8080. I can try to test my Spring Boot Maven application. For the same, let me go to the Postman. Here inside my Postman, I'm trying to send a post request to create a new account. These are the details, like what is the name, what is the email and mobile number. So let me click on the send button. You can see I'm getting a proper successful response from my container. And I can also confirm if my account is created or not by invoking a get API. So this API will fetch the account number details based upon the mobile number that we have given during the create account. So I have given the same mobile number. Let me click on this get command. You can see I'm getting a successful response with my account details. So this confirms we successfully convert our Spring Boot application into a Docker container. Before I try to jump onto the second approach on how to containerize our Spring Boot application, first let me tell you what are the advantages and disadvantages with this approach. The advantage that we have with this approach is, as a developer, you have complete control on how your Docker image is going to be built. If you are an expert on Docker, you can give proper complete instructions to your Docker server, and from the instructions, a Docker image will be generated. But please note that whatever we have done, this is very basic approach. There are more challenges that you need to consider, like performance of your Docker image, security for your Docker image. So if you try to bring all those aspects, you need to be a master of Docker and how to give instructions with the Dockerfile. So in order to get the advantage with this approach, which is like you are the owner on how to create the Docker image with your own requirements, there is also a disadvantage, which is there is a lot of learning curve for the developer where he needs to master the Docker instructions. So to overcome these challenges, we have the second approach, which is Buildpacks. So here you may have a question, what is Buildpacks? Buildpacks is a library that transforms your application source code into the Docker images that you can run on any cloud environment. You can confidently rely on this option because this Buildpacks is built by the experts from the organizations Heroku and Pivotal. Based upon their years of experience, they build this Buildpacks library and tools using which a developer can transform his source code into a Docker image without any Docker knowledge. I'm saying again, the developer can have zero Docker knowledge, but he can still generate a Docker image for his Spring Boot application. So that's the magic of Buildpacks. So let's try to discuss how to generate a Docker image with the help of Buildpacks. Before that, let me try to stop my running container by pressing Ctrl C. This will stop my running container. I will also delete my Docker image, which got generated with the help of Dockerfile. Before that, let me delete my stopped container from my Docker server, and post that I'm going to look for my Docker image with the name accounts, and this is the Docker image that we generated with the help of Dockerfile. So please observe here the size of Docker image that is generated with the help of Dockerfile is 450 MB. So please make a note of that. So let me delete this Docker image. Now as a next step, I'm going to create a new folder inside my workspace location, and this folder name is going to be 02-Buildpacks because this is the second approach. And inside this Buildpacks folder, I'm going to paste the same accounts Maven project from the previous approach that we have discussed. So I'm pasting the same here. Now inside this accounts project, I'm going to delete the Docker file that we have created previously because we want to explore the second approach with the help of Buildpacks. Like I said, with the Buildpacks, you don't need to give any Docker instructions inside this Docker file. So that's why let me delete this file. Now I'll go to my IntelliJ IDE. Here I'm going to open my new Maven project by going to this open and selecting my accounts project present inside this Buildpacks folder. So let me open this. Like you can see, the Maven project is imported into my IntelliJ. So here there is no Docker file. Now, in order to generate a Docker image with the help of Buildpacks, the only change that you need to do is inside your pom.xml. Inside your pom.xml, inside this plugin configuration, you need to provide what is the image name that Buildpacks has to consider when it is trying to containerize your Spring Boot Maven application. So I'm trying to give the same information here. So you can see with these image configurations, I'm telling my Docker image name should be EasyByte/ and the value that I have assigned inside this pom.xml under the artifact ID. If you can scroll up here, the artifact ID that I have here is accounts. So the same will be considered inside this placeholder. So this is the only configuration that you need to do. Of course, we can also pass this image name when we're trying to execute a Maven command, but I would always recommend you mentioning the Docker image name inside your pom.xml so that regardless of which developer is trying to generate a Docker image, the image name is going to be always the same. Now let me go to my terminal. So here I'm going to execute the clear command. Post that, I need to navigate to the folder where my approach to accounts project is available. So let me go back one more time. And here the folder that we need to navigate here is 02-buildpacks and accounts. So to this folder I'm trying to navigate. Now we can try to execute a maven command which will generate the Docker image of your Spring Boot application. Before you try to run this maven command, please make sure your Docker server is running behind the scenes. Even in the Dockerfile approach also, whenever you're trying to generate a Docker image, we need to make sure that Docker server is running behind the scenes. So here the maven command that I want to execute is maven spring-boot build-image. If you run this maven command behind the scenes, the Buildpacks will do all the heavy lifting for you. Even though you have not given any Docker instructions on how to generate the Docker image of your application, behind the scenes, my Buildpacks is going to analyze your application. What is the Java version that you are using? What are the dependencies that you are using? So based upon all the dependencies that you have defined inside your pom.xml, it is going to generate a Docker image. And while generating the Docker image, it is also enforce all the production grade standards like security standards, performance standards, caching. I don't even have to worry about all those Docker standards because now all the heavy lifting is being taken care by the experts who build the Buildpacks. So it will take few seconds. So let's wait for a few seconds here. You can see here my Docker image is successfully generated with the name that I have given, like the name is easybyte/accounts, and by default the registry will be docker.io. So registry is the place where we can store all our images in a remote repository. By default the Docker server is going to consider the docker.io as the registry. That's why you can see the complete name of the image as the registry value, which is docker.io. So now I can go to the Docker dashboard. So here you can see the Docker image generated, and this time the size is 305 MB. So this is a drastic improvement, and I'm able to achieve all these improvement without any knowledge just by using Buildpacks inside my web application. So to use Buildpacks, I didn't install anything. I'm just trying to use a maven command which will inbuilt take help from the Buildpack. So now I can try to create a container from this image. For the same, the command is going to be the same, which is docker run -p 8080 easybyte/accounts. So I'm trying to execute the same, and this will create a container based upon my image. My container started successfully at the port 8080. Now I can go to the Postman and do some sanity testing. So here, if I try to directly invoke the get API, of course, you will not get any data. You will get an exception because we are using internal H2 database. So whenever a restart or whenever a new container is being created, all the data that we previously created will be wiped off. So let me try to create the account again. So I'm trying to create the account. I'm getting a successful response. Now I'm trying to invoke the get API, and you can see I'm getting the successful response. This confirms our second approach is also working fine. Now let me go to the third approach, which is using Jib. I'm going to talk what is the difference between second and third approach, what are the advantages and disadvantages once we discuss about the third approach. So first, let me try to stop my container by pressing Ctrl+C. Post that, I'm going to clear the console. After this, I'm going to delete my container which I have created so that we can test the third approach as well. So I'm deleting the Docker image. So the Docker image size reduced from 450 MB to 305 MB. So let's try to understand what is the size that it is going to generate when we are using the third approach. So let me delete my Docker image. So now what I'm going to do is I'm going to copy the same Buildpacks folder into the same workspace and rename this to the 03-Jib. So Jib is the third approach. And with this, we should be good. Let me try to import this new Maven project, which I have copied inside the Jib folder. So I'm clicking on this file, open, and inside my storage, workspace, Spring containerization, and inside this, I have a Jib folder, and here I have accounts Maven project. So let me click on this open. So here, first, I need to remove the changes related to the Buildpacks. So the changes that I have here related to the Buildpacks is this image configuration. So let me remove this. Before I try to make any changes related to the third approach, which is Jib, let me try to give a quick introduction about what is a Jib. If you can go to the URL github.com/Google Container Tools/Zip, you should be able to see all the details related to what is this zip. The full form of zip is Java Image Builder. So that's a full expansion of zip, and this library or tool is built by the Google itself. Using this zip library, we can convert our Java-based application into a container that can be deployed inside any cloud environment. So there are multiple ways on how we can use this zip approach. We can use with the help of Maven and Gradle. Even Buildpacks also support the Gradle approach. If you are using Gradle, please look for the equivalent Gradle commands of Maven commands that I have used. So here, if you can scroll down, there is a quick start, and inside this quick start, there are multiple approaches like with the help of Maven and with the help of Gradle. So let me click on this Maven quick start link. Before we try to explore the configurations on this page, let me give a primary difference between zip and Buildpacks. The primary difference or the primary advantage with zip compared to Buildpacks is whenever you're trying to containerize your Spring Boot application, with the help of zip, you don't need to install Docker inside your local system. And this is going to be a big savior for the developers who just want to convert their source code into a Docker image, because they can avoid the complex process of Docker installation. And one of the reasons why people use zip compared to Buildpacks is, suppose your organization may have CI/CD pipelines. Inside those CI/CD pipelines, you may have a step to build your application and convert your application into a Docker image. And after the Docker image conversion happens, obviously the CI/CD pipelines, they will push that Docker image into some Docker Hub repository or any other registry repository from where the frameworks like Kubernetes will try to fetch your Docker image and initiate that deployment process. So inside the CI/CD pipelines, you're not creating any container of your application. You just want to build, convert that into a Docker image and push into a remote repository. So if you use the Buildpacks approach, you will end up installing the complex Docker setup inside your CI/CD pipeline servers. So to make your CI/CD pipelines lightweight and to avoid the Docker installation, you can use the zip approach. So that's a second major advantage that we have. So we have advantage both during the local development and even inside the CI/CD pipelines as well. The thumb rule is, if you don't want to create a container and you just want to create a Docker image, you can always go with the zip approach. So let me show you the demo on how to generate a Docker image without Docker installed inside the local system. For the same, first I'm going to stop my running Docker inside my local system. So I'm just clicking on this quit Docker desktop. So now you can see my Docker server is not running inside my local system. I can also confirm the same by running a command which is docker images. You can see there is no Docker daemon running. That's why I'm not getting any successful response. Now coming to the configurations that we need to do inside our Spring Boot application is, like you can see inside our Maven Java project, we just need to copy these plugin details inside the pom.xml. So let me take these values, and here inside our pom.xml, we already have a plugin. Just after this existing plugin, I'm going to create a new plugin with the details that we copied from the zip GitHub repository. So here under the image tag, we need to provide what is the image name that we want to consider for our application. So here the image name that I want to consider is the same, which is docker.io/easybyte/ what is the artifact ID. The reason why I have mentioned docker.io here is, since we are trying to generate a Docker image without the help of Docker server inside my local system, the behavior of the zip will be, it will try to convert my Spring Boot application into a Docker image, and it is going to push that Docker image into the registry that I have configured. So the registry that I have configured here is docker.io. So let me save these changes and do a Maven refresh. Now I can go to the terminal. Inside my terminal, first I want to navigate to the folder location where we have the third approach, which is 03-zip. This is the folder, and inside this folder we have accounts Maven project, and here I have to execute a Maven command. Let's go to the GitHub to identify what is the command. So here we have two types of command. The very first command we should use whenever we want to generate a Docker image without the help of Docker server inside the local system. So you can see I'm copying the same command and I'm not using this image argument because I already configured this image name inside my pom.xml. So I'm going to execute the maven command, which is maven compile com.google.cloud.tools zip-maven-plugin, and what is the version, and at last we need to mention the command which is build. So if I try to execute this, you can see the zip library is trying to scan my web application, and once the scanning is completed, it is trying to generate a Docker image. Once the Docker image is generated, it is also going to push the Docker image into my remote Docker Hub repository. So you can see it is trying to push my Docker image. Once this is 100% complete, we can go to the Docker Hub website and validate if this image is really pushed into my remote repository. The task is 100% completed. Now I can go to the Docker Hub website. So this is the website hub.docker.com. Now if I go to my repositories, you can see there is a new image pushed into my remote repository just few seconds back. But the same image is not available inside my local system because this never stored inside my local system due to the reason that we never started or installed Docker inside our local system. And here you may have a question like how Jib is able to push the Docker image into my Docker Hub without knowing my username and password of this Docker Hub website. For the same, if you can observe these logs that are printed, my Jib will try to look for the credentials inside my local system, and it found some credentials inside my Docker config. Since I have Docker installed inside my system and I have used Docker inside my system previously, the credentials are stored somewhere inside my system. Using the same credentials, my Jib library tried to push the image into the Docker Hub. That's why it worked perfectly inside my system without giving username and password. But if you never install Docker inside your system and you never use Docker inside your system, you need to pass the username and password of the Docker Hub to the Jib library. The details on how to pass the username and password are mentioned inside this page. Like if you can look for username and search for the username, you can see here, this is how you need to pass the username and password with these variables. You can see there is a simple command that they have given where I don't even have to make any changes inside my pom.xml. I can straight away mention what is the image name, what is the username and password, everything inside my maven command itself. I hope this is clear. Now let's try to run the container from the Docker image that we have created with the help of Jib. So the command is going to be the same, which is docker run -p8080 easybyte/accounts. But you will get an error because the Docker is not started inside my system because I'm trying to convert an image into a container. So that's why we need to make sure we are starting the Docker. So let me start the Docker inside my system. Once the Docker started successfully, we can run the same command, and since my Docker does not have this image inside my local system, it will fetch the Docker image from the remote repository. So let me try to execute the command. You can see the very first line, unable to find image locally. That's why it is trying to pull the image from my remote repository, which is Docker Hub. Once it pulls the image from my remote repository, the creation of the container will start. Post that, we can validate the container by doing some sanity testing with the help of Postman. So let's this process complete. The image pulled successfully. Now my application or container is being started. Meanwhile, let me go to the Docker desktop and see what is the size of the image name. You can see the size of the image that is generated with the help of Jib is 317 MB, whereas with the help of Buildpacks, it is 305 MB. So there is no major difference. Both approaches, they are doing a good job in compressing the Docker image by following all the Docker standards. So now let me go to the Postman. So first I'll try to create the account with the help of this create API. So the account is created. Now I'm trying to fetch the account details. This confirms that my third approach is also working fine. I hope all these three approaches are clear to you. Now you may have a very big question, which is what is the differences between them, under which scenarios I should use which approach. The very first approach, which is Dockerfile, is very straightforward. You should consider it when you have complete knowledge on Docker and you are an expert about the standards of Docker, like how to achieve better caching, better compression, better security for your container image, then you can go for the Dockerfile approach, because that will give more flexibility to you as a developer. Now coming to the second approach, Buildpacks, and the third approach, Zip, there is no major difference between them. Usually developers who don't want to install Docker inside their local system, they will use the Zip approach. But if you ask me which is better in both Buildpacks and Zip, I would say Buildpacks is more better compared to Zip. When I say better, I'm not saying that Zip is bad. To some extent, Buildpacks do a better job compared to Zip. The reasons are very clear. If you try to go to the website of Buildpacks, there is a clear comparison given by the Buildpacks team about all the approaches that we have. Like the very first approach is Buildpacks, the second approach is Dockerfile, and we also have Zip here. And apart from that, they also have other approaches which we can ignore. So you can see there is a lot of comparison done by the Buildpacks team, and majority of the advantages are on the Buildpacks. Like advanced caching is not available in Dockerfile and Zip, and auto detection is not available in Dockerfile. And one more primary advantage of Buildpacks is multi-language. Buildpacks supports various languages like Go, Node.js, Java, .NET, Python, whereas Zip is completely a Java focused library. That's why I always recommend you using Buildpacks, because when you are developing microservices or serverless components inside your application, we never know when our client will ask to change a language for a new service from Java to Python or Java to Node. So to handle such scenarios, Buildpacks is very good. And apart from that, you can see coming to the integrations, Buildpacks has lot many integrations, like with lot many pipelines like Azure, GitLab, Google, Heroku. So there are many integrations provided by the Buildpacks. I hope you're clear here. Now, if you go to the official documentation of Zip, you may have a question like, can't I generate a Docker image in my local system where I have installed the Docker as well, just like Buildpacks? Of course, we can achieve that with the help of Zip as well. The only change that you need to take care is to use a different Maven command. The very first command, which is build, is going to generate a Docker image without the help of Docker server inside your local system. Whereas if you use a command which is docker build, it is going to generate the Docker image with the help of Docker server inside your local system, and the Docker image is going to be available inside your local system, and it will never be pushed into the remote repository. I hope you're clear. And similarly, if you can scroll down, there is a lot of details on how to push the Docker image automatically into the Google Cloud registry, AWS registry, Docker Hub registry, similarly JFrog container registry, Azure container registry. There are a lot many details which you can explore based upon your requirements. At last, before closing this video, I want to share details about the GitHub repository. So this is the GitHub repository which I have created for this video purpose. You can see I have uploaded all the three approaches that we have discussed: Dockerfile, Buildpacks, Zip. And apart from that, I also mentioned all the commands that we have used under this README document inside this repository. So please feel free to refer to this repository for more details. I'm going to mention this GitHub repository link inside the video description. If you are looking for more detailed courses about Spring Boot, microservices, or any other framework, please feel free to refer my official website, which is easybytes.com, where you can see all the Udemy courses from me, and feel free to register for the same. With that, I'm super happy that I'm able to share this knowledge with you. And I'm also assuming that you are clear about how to containerize a Spring Boot application with all these three approaches. Before you closing the video, please make sure you're liking the video and subscribing to the channel. Thank you and catch you later. Bye.